Hello students, welcome back to A-Star Tuition channel. Today we will learn about the quadratic function, its graph, as well as how to solve the quadratic equation. Let's get started. Okay, so the quadratic function that we are discussing here is in the form of y equal to ax squared positive bx positive c. This is the general form of quadratic function. Now, the first technique that we'll be learning here is to transform this quadratic general equation of quadratic function into the completing the square form, which is in the form of the following. Okay, so referring to this, we need to factorize this a and make sure that the coefficient of x squared equals to 1 while keeping the constant intact. Yeah, so this is gonna be a times the big bracket x squared positive b over ax positive c. Okay, recall the expansion of this. Which is equal to x positive d times x positive d, which is equal to x squared positive 2dx positive d squared. Okay, so this is what we have, and we need to modify this so that it's gonna be like this, so that we can eventually express this as this one. Okay, how do we do that? Take a look on these two. There's a coefficient of 2 here. Therefore, this b over ax could be written as 2 times b over 2ax positive c. Now, this is the d here we are having now. This is the d we are having now. Okay. Notice that we also need a d square here, but we don't have it here. So, how do we create the d square? We can modify this form again slightly, so that we have the d square. This is b over 2ax. Okay, the trick here is to just write it as positive d square, b over 2a square. Okay, but this was created from nothing, and we need to remove it again with b over 2a square, so that we don't change the following form. This is exactly equal to this. Okay, we add it with this square, but then we take it again by the same term square. Okay, now these first three terms resemble to the three terms on the right hand side of this expression. Okay, x squared positive 2dx positive d square, x squared positive 2 times this is dx positive d square, and therefore now according to this could be written as x positive d square. So this is b over 2a square. Okay, while this negative b over 2a square will stay there. Alright, so this a now could be distributed to both components inside this big bracket. So now we can remove the big bracket. Then the next step is going to be x multiplied by this, x positive b over 2a square negative, this is a multiplied by b square over 4a square. So the a here over a square could be written as a on the denominator here. Okay, this is a over a square, so that we have a on the denominator. So now this is the completing the square form from the general quadratic function. Now we're going to also discuss on how to find actually the x-intercept from the following completing the square form. We're going to find the x-intercept from this equation. X-intercept is defined as the value of x when y is equal to 0. So we're going to equate this to a 0. Okay. Doing a little algebra. These two terms will be moved to the right hand side, and then we'll divide both sides by a. Okay, next is to equate the denominator of this by multiplying this by 4a over 4a. So we have 4ac over 4a square. Okay, this square right here could become the square root of the right hand side that comes with a sign positive or negative here. Okay, next square root of a square is equal to 2a, so this could be written as square of b square negative 4ac over 2a. And finally, this x is equal to negative b over 2a plus minus square root of b square minus 4ac over 2a. Because they both share the common denominator, so we could write it as negative b positive negative root of b square minus 4ac over 2a. Okay, so this is the formula of finding the x-intercept from the general quadratic function. Please take note of this because we will use this repeatedly throughout this chapter. Okay, next we're going to rewrite x1 as negative b positive square root of b square minus 4ac over 2a, while the second root is the negative portion. This is this positive, this is negative. Negative b root square of b square minus 4ac over 2a. Okay. In addition to this, we are also interested to find the midpoint. Okay. The midpoint is defined as the average of these two. So it's x1 positive x2 over 2, which is equal to negative b positive square root over 2a, and then positive again of negative b negative square root over 2a divided by 2. Now this square root will cancel this square root, so we will have negative 2b over 2a divided by 2, and this is going to give us negative b over 2a. Okay, this is called the x of the midpoint. Okay, to find the y-coordinate of the midpoint, we just need to plug this back into the general equation, which is ax squared positive bx positive c. The x here is to be replaced by the following. So this is going to be b squared over 4a. This a is on the numerator, while this a squared is on the denominator, so it's going to be just 4a on the denominator. This is negative b squared over 2a positive c. We can equate the denominator by multiplying this by 2 and 2. So we multiply by 2 over 2. So it's b squared negative 2b squared over 4a positive c to give us this. Okay. So the coordinate of the midpoint is negative b over 2a, comma, this is the y of the midpoint, negative b squared over 4a plus c. Yeah. Moving on. I also would like to introduce the concept of discriminant. Okay, discriminant. What is discriminant? Basically, this b squared minus 4ac inside the square root, due to the repeated use, is defined as the term discriminant. Okay, we're going to analyze the nature of the quadratic function for the case when the discriminant is positive, equal to 0, and negative. Okay, now when the discriminant is positive, so this b squared minus 4ac is positive, then the quadratic function has two distinct real roots. Okay, why two distinct real roots? Because there is a positive as well as negative solution here. So when the b squared minus 4ac is positive, there are two distinct real roots. Yeah, so one is negative b positive square root of such thing over 2a, and another one is negative b negative square root of such thing over 2a. So the result will be two distinct real roots. Okay. Now, when the value of the discriminant is equal to 0, let's take a look and analyze this closely. This is going to be 0 because square root of 0 is 0, and we will have negative b positive 0 over 2a, and another one is negative b negative 0 over 2a. Yeah, so they both actually display the same value. positive 0 and negative 0 basically leads to the same number. So for that reason, the conclusion made is there is only one real root, or some people call it as two equal roots, okay, or two equal roots. Okay, let me emphasize one more time. The reason is because this is equal to 0, so positive 0 and negative 0 leads to the same number. Now, when the value of the discriminant is negative, so this whole term inside the square root is negative, then there is no real root, because square root of negative value is not a real number. Okay, you will learn it further in the complex number, which is so-called imaginary number. So the conclusion for the following is no real root. Okay? Okay, moving forward, we will discuss the graph of quadratic function. So y equal to ax squared positive bx positive c. When the value of a is positive, the graph will be a concave up graph. Okay, it's a concave up, but we also need to pay close attention to the discriminant that we just discussed. So when the discriminant is positive here, there are two distinct real roots. So the graph would look as the following. There are two real roots here to be observed, and the graph is concave up here. Okay. Next condition is the graph that has a positive value of a, while the discriminant value is equal to 0. Now this is also another concave up graph which only has one real root. So the graph would look like this. It only has one real root, so the graph has to be touching the x-axis here. There is only one real root here. Okay. Next is the graph that has condition a positive and discriminant is negative. This is another concave up graph which does not have the real root, so the entire graph has to always be above the x-axis. The graph would look as the following. Okay. This is what we call as the turning point. Yeah, the midpoint, turning point. Okay. Next condition for the negative value of a, while the discriminant is positive. When a is negative, the quadratic function or the graph of the quadratic function has to be concave down. Okay, while there are two distinct real roots, so it's going to look like this. This is the general graph of quadratic function having the following properties. Okay. Moving forward, we have two kind of graphs to be covered. This is for a less than 0 and discriminant is equal to 0. So there is only one real root and it has to be concave down. It's going to look like this. And finally, when a is negative and discriminant is negative, it's a concave down graph, but it has no real root. So the graph would look as the following. Okay, now moving on, we're going to present the graph of each of these functions. Okay? However, before doing so, I need to also pass this to you that there are three different forms of the quadratic function you will most likely encounter throughout this chapter. Okay, the first is called the completing the square form, which is in the following form. The second form, this is completing this square form, and the second form is called the X-Intercept form, while the third form is the general form. Okay, if you deal with the completing the square form, it is actually pretty straightforward to graph the following function. All you need to do is first identify the turning point. What is the turning point? The turning point is either the minimum or the maximum value. But for this function, because the coefficient of x squared, which was defined as a previously, is a positive number. This is the a, which is positive. So the graph has to be a concave up graph. Okay. Now a concave up graph has a minimum value here. It has the minimum value, and the minimum value of such equation could be found by setting this to be 0. Okay. Why is it that way? Because this y reaches minimum when this is minimum. Yeah, y reaches minimum when this is minimum, and the minimum value of any number square is 0. Okay, because positive square is positive, 0 square is 0, negative square is positive. So as you can see that this y reaches minimum when this is 0. Okay, 0 square is 0. If this is negative, negative square is positive. Now, the corresponding value of x that cause this to be 0 has to be equal to 3. Yeah, y reaches minimum when x is equal to 3. And the corresponding value of y is equal to 2 times 0, negative 8, which is negative 8. This is called the turning point. And this point right here is called the Y-intercept. What is the definition of Y-intercept? Y-intercept is defined as the y value when x is equal to 0. So the corresponding y value will be 2 times 0, negative 3, negative 8. 0, negative 3 is negative 3. Negative 3 square is 9. So we have 2 times 9, which is 18, negative 8 is a 10 here. Okay. Now, these two x-intercept could be found by setting the y to be equal to 0. Again, the function has two distinct real roots only if the discriminant is positive, as was discussed previously. Okay, now to find the x-intercepts, we can set the y to be 0. So 0 is equal to 2 times x negative 3 squared negative 8, making x negative 3 squared as the subject would give us a 4 here. And therefore x negative 3 will be positive or negative 2. We have x1 equal to 3 positive 2, which is a 5. and x2 will be equal to 3, negative 2, which is a 1. So now we know that the coordinates of the x-intercepts are 1, 0 as well as 5, 0. Okay, it's as simple as that. Going to the second form of the quadratic function, this is the X-intercept form. If you deal with the given function in the following form, it is even easier to draw the graph. Okay, first of all, you will have two x-intercepts at 1, 0 and 5, 0. Again, x-intercepts is defined as the x value when y is equal to 0. So y is 0 when either this is 0 or this one is 0. Therefore, we have 1, 0 and 5, 0. Because the value of a is a positive number, therefore it has to be a concave up curve. So we will draw it this way. Yeah, this is the turning point. Okay, we can find the turning point using a different approach here. Okay, the first approach that I was teaching you just now still work, but it will be more challenging actually to convert this form into this form. So we are not going to use the same approach as what we did in the previous case. Now we will just use the concept of the midpoint here. Okay, this turning point or the minimum point is actually the midpoint of these two x-intercepts. So we can find the midpoint by taking the average of the two x-intercepts. So what you are going to do is we are going to add these two, divide by 2. 1 positive 5 divided by 2, which is giving you a 3. And the corresponding y value could be obtained by plugging this back into the original function. So we will have 2 times 3 negative 1 multiplied by 3 negative 5. This is giving you 2 times negative 2, which is equal to negative 8. Now this coordinate right here is 3, negative 8. Okay, it's as simple as that. For the last form of the equation here, because we are presented with the general form, so again you have two options to do this. If this could be factorized, you could present it into the following form. If it can't be factorized, then you can only present it in the following form. Okay. However, here in this example, I'm just going to convert this into completing the square form. Okay. You're going to learn further later after we are done with the graph on how to factorize the quadratic function. Next, using the same approach as what we discussed earlier, we will ensure that the coefficient of x squared equal to 1. So by factoring the 2 here while keeping the constant intact here. So then the terms inside the bracket will be equal to x squared negative 6x. The positive 10 remains to be there. Okay, and then this x squared negative 6x could be written as x squared negative 2 times 3 times x here. Okay, the whole purpose is to find the square of this. 3 squared is a 9, so then we can add it by this square and take away the same term as well. Okay, if you are still confused up to this step, I would suggest you to go back to the technique at the beginning, technique of the completing the square at the beginning of the video. for the review purpose, okay, before you coming back to this. And then this whole thing, the first three terms right here could now be written as x negative 3 square by expanding the whole terms inside the bracket. We will have 2 times x negative 3 square negative 18 positive 10, which is equal to this. So again, this is completing the square form, which is exactly the same as this. And to graph this, we just need to repeat on what we did here earlier. So I guess that is it for the lesson on how to graph the quadratic function. Okay, next we'll also find the sum and the products of the roots of quadratic function. Yeah, so x1, recall that x1 is equal to negative b positive square root of b squared minus 4ac over 2a, while x2 is negative b negative square root of b squared minus 4ac over 2a. So the sum of the roots is equal to negative b positive root of b squared minus 4ac over 2a positive negative b negative root of b squared negative 4ac over 2a. Now because they both have the common denominator, so we can actually combine them right away, and this term will cancel this up. So the numerator will be equal to negative 2b over 2a, which is essentially equal to negative b over a. Okay. In addition to that, the product of these two terms will be negative b positive square root of b squared negative 4ac over 2a to be multiplied by negative b negative square of b squared negative 4ac over 2a. Okay, the numerator will be b squared. Okay, this time this will be positive b square root of b squared minus 4ac. The product of this and this will be negative b times square of b squared minus square root of b squared minus 4ac, and then final term will be the product of these two terms. Okay, now because they are identical, so the product of them will eliminate the square root. Then we will have b squared minus 4ac. Do not forget to place the bracket here because this negative belongs to both terms right here, and the denominator will be equal to 4a squared. This will cancel this up, and then when you open up the bracket, this b squared negative b squared, this negative encounters another negative, which turns to be positive. So we have positive 4ac over 4a squared. Okay, this b squared cancel this b squared, and finally we have c over a. Because this 4 cancel this 4, a over a squared leaves a on the denominator. Okay, so moving forward, we are going to discuss the technique of solving quadratic equation now. Okay, there are in general 3 forms of the quadratic equation, and I'm going to show you the technique of solving each of them separately. Okay, next is solving quadratic equation using 3 different methods. Okay, The quadratic equation we're solving here is 2x squared negative 7x positive 3. This is just the random quadratic equation that come across my mind just now. Okay, so the first technique is called factorization. Okay, please bear in mind that not every quadratic equation could be factorized. Yeah, this just happens to be the quadratic equation that could be factorized. The technique of doing this is as the following. You need to find two numbers in which the sum is equal to this one. Okay, which is negative 7. While the product is equal to the product of these two. Okay, 2 times 3, which is equal to 6. So we need to figure out those two numbers that satisfy the following conditions. Okay, and it's not difficult for us to just come up with negative 1 as well as negative 6 for those two numbers. Okay, now after you figure out these two numbers, what you need to do next is to split the middle term right here into those two numbers we just figured out. So negative 7x could be written as negative 1x and then negative 6x. There we go. Okay. Next step is to factorize the first two terms as well as the last two terms here. Okay. Now we're going to pull out the common term of the first two terms. Okay, which is an x. So we will factorize the x, and the terms remaining inside the bracket will be equal to 2x negative 1 right here. Okay, likewise, for the last two terms, we also will pull the common term out, 6 and 3. We know that they both have 3 in common, and this negative could also be essentially pulled out, so we will have negative 3 right here. Okay, initially it was negative 6x. Because negative 3 has been pulled out, then the 2x will stay here. This is positive 3, negative 3 is pulled out, then we should be having negative 1 right here. Okay. Then we will also factorize the common terms from these two terms. They do both have 2x negative 1 in common, so we will pull 2x negative 1 as well, and the terms remaining inside the bracket will be x negative 3 right here. Okay, so now we have come up with a beautiful equation here, and the product of two terms is equal to 0 only if either the first term equal to 0 or the second term equal to 0. So we are going to solve them separately here. 2x negative 1 equal to 0 as well as x negative 3 equal to 0, and this x is giving us 1/2 while this x is giving us a 3 here. So this first technique is called factorization. However, as mentioned earlier, that not every quadratic equation could be factorized. Yeah. Okay. Second technique, completing the square. This technique was earlier discussed twice at the beginning of the video, and if you're not familiar with this, I would recommend you to go back to the early part of the video and make sure to have some mastery on it before you actually can come back to this one. Okay, so now what we need to do is we'll have to make sure that the coefficient of x squared is equal to 1 while keeping the constant intact here. So we will factorize the 2 right here, and we have x squared negative 7 over 2x inside the bracket. Okay, and then we also need to have the 2 right here. So this 7 over 2 will become 7 over 4 times x. Yeah, positive 3. Okay. Remember that we need to add this by 7 over 4 square, but this 7 over 4 square was created from nothing, and therefore we need to also remove the 7 over square again right here. And remember that the first 3 terms now could be written as x negative 7 over 4 square. Okay, and this negative 7 over 4 square will still stay there. Alright, next we will just distribute the 2 by opening up the bracket. So we have 2 times x negative 7 over 4 square, negative 7 square is 49, 4 square is 16, but there is a 2 on the numerator here. So when we bring it to the other side, that will become 49 divided by 8 here, because this 2 over 16 could be written as 1 over 8, and positive will become negative. Okay, then equating the denominators of these two will give you 3 times 8 is 24 over 8. The 2 is staying there. This is give you 25. So 25 over, let's divide both sides by 2. So 8 divided by 2. This divided by 2 again, so the 8 gets multiplied by 2, so this is 16. And then we'll have x negative 7 over 4 equal to positive or negative square root of 25 over 16, which is equal to 5 over 4. So the first x value is 7 over 4, positive 5 over 4, which is 12 over 4, which is also equal to 3. And the second solution is 7 over 4, negative 5 over 4, which is equal to 2 over 4, and that's equal to 1/2. Okay, these answers are consistent with the ones we got using the factorization technique. Okay, so that is it on the completing the square technique on solving the quadratic equation. The last technique here is called the quadratic formula. And the formula was derived earlier at the beginning of the video. The x is negative b positive negative square root of b squared negative 4ac over 2a. Okay, now before we actually start using this, we need to be able to identify the values of a, b as well as c. A is the coefficient of x squared, which is equal to 2. B is the coefficient of x, which is equal to negative 7, while c is the constant, which is equal to 3. So all we need to do is just plug in these 3 numbers into the following formula. That is going to give us negative of negative 7, positive negative square root of negative 7 square, negative 4 times 2 times 3 over 2 times 2. Okay, so this is going to give us 7 positive negative root of 49 negative 24 divided by 4, which is leading to 7 plus minus root of 25 over 4. This is a 5, so we have 7 positive negative 5 over 4. x1 is equal to 7 positive 5 over 4, which is giving us 3. And x2 is 7 negative 5 over 4, which is giving us 2 over 4, which is equal to 1/2. And once again, that the results of these are also consistent with the result from the second technique as well as from the first technique. So I guess all the techniques of solving the quadratic equation have been presented, and we have come to the end of the explanation of this chapter. So thank you for watching this video. Please comment, like, and subscribe this channel. See you again in the next video. Bye bye.